Hello, awesome developers. Welcome back to my channel. In today's course, we are diving into something super exciting. That is building CRUD Web API in .NET 8 while following solid principles and clean architecture. Whether you are a beginner or an experienced developer, this is going to be fun, engaging, and most importantly, practical. What actually is solid? Well, first let's talk about solid principle. Imagine you are building a house. You wouldn't want to mix up the plumbing and the electrical wiring, right? The same goes to our code. Solid principles are like the building blocks that helps us design software that is easy to understand, maintain, and extend. So solid principles are the guidelines that helps you, the developer, to build a system which is maintainable, understandable, and easy to use. I believe this is simple, right? The most simplest ever definition that you've got. Alright, now with solid is an acronym. Now, acronym, we have each character representation, and that's what you see on the screen. So here we are having single responsibility principle, SRP. That is what the S stands for. And I believe you can read the rest up to OLID, right? Now don't worry about this too much. When we are done, we're going to analyze our project or our code following these principles and see whether we're able to go along or we made something which shouldn't have been in that way. I told you earlier that we are not only implementing solid in our CRUD API, we are also following the best architecture ever, that is a clean architecture. So let's also talk about clean architecture. Think of it as a blueprint that structures your house, or in this case, your application. It separates the inner working of your application, like the data and business logics, from the outer layers, like the user interface and external APIs. This way, you can renovate one part of your house without knocking down the whole things. So what is the importance of combining these two magics? That is the clean architecture with solid principles. Well, when we combine solid and clean, we get a robust, scalable, and maintainable application. It's like building a let-go set. You can add or remove pieces without the whole structure crumbling down. Aside from this, there are actually three benefits of doing that. One is, it is easy to update and fix bugs or issues without affecting the other part of the code. You can work with the back end without affecting the front end. That is one advantage of it. Aside from that, you can also add new features without rewriting existing ones. In case you have your application in production and you want to add another feature, it becomes very easy for you to do it because the interfaces are there. The place to do it is there. And all that you need to do here is to insert your code and boom, you have everything set. And the last part here is for testing. Unit testing or testing unit in your code becomes a breeze since each piece of the code does only one thing. That is by following the solid principles. Okay, then what are you looking forward in this course? Let me tell you. We're going to build a simple CRUD, which stands for Create, Read, Update, and Delete, Web API in .NET 8. Actually, this cuts across .NET 7, .NET 9, yes. And also, we're going to apply these solid principles to our project. And at the end, we are following the clean architecture pattern to structure our solution so that each part of the code is independent, organized, and easy to maintain. So by the end of this video, you will not only have a fully functional CRUD API, but also a deep understanding of how to apply solid principles and clean architecture to any project you work on. Let's get coding. Maybe I've shown you the steps or what solid principle is. Actually, you've seen what each character does, right? What of the clean architecture? also has its diagram here. Let me show you. Now, clean architecture, actually, it is just a simple and clear architecture which helps us to build great applications. Now, when you look at this, we have, I think, 4 main layers. We have the domain layer, that is the core, independent. We have the application, which depends on the domain for business logics, models. And now this application contains our use cases, simply our consumers. And domain contains our models or our entities or DB sets, which is what we're going to use to form our database tables. Now we have the infrastructure, which contains the external services. Now these external services are the DB context, repository, so your DB context, and in case you're going to have access to any external service, you're consuming an external API, you're doing a whole lot. That is where the magic comes in. So if this get access to your database or your external service, then you have your endpoint. That is where you have your presentation. And well, it's a presentation layer. That is where you have your UIs. Talking about the UI is your API project. Talking about maybe Blazor web app project. So these are the presentation layer. They consume this infrastructure and also the whole set of these layers. So when you build your project like this, each become independent, and it becomes very easy for you to add new feature without breaking the existing code. Well, let's get into it and let's see how we can put this into practice. Make sure you have a Visual Studio 2022 or higher launched. I'm going to use .NET 8. This course is for everyone, from beginner to advanced. We can learn. Yes, we can get some insight from this. Now let's create project. So here, in order for us to organize this, we need to create a solution, and under this solution, we're going to be adding our 3 libraries, which are going to be class libraries. Then we add our endpoint, or maybe a UI, which is for an API. So let's get this done. And as you can see from our architecture, we're having this layer. So I'm going to maintain these layers. In order for you to see, you can actually change the name. Okay, you can change from presentation, application to any other name, but the context, the function should be the same. Changing doesn't matter. The context should be the same. So, but for the sake of this, I'm going to maintain this. So I need to create a presentation. That's going to be our API. I'm going to create class library for application, domain, and infrastructure. Okay, so we first need to create our blank solution. So when you check our solution, you can see that we are having these 4 layers. We have our application, our domain, our infrastructure, and our presentation, which come together to form the clean architecture. The next thing to do here is to create dependencies. Now, domain is independent, meaning it does not depend on anyone. Application depends on this domain. So we're going to include that in here. So what we're going to do here is application, right-click on dependencies, add project references. Then we're going to add the domain. Infrastructure depends on this application. So right-click, add application. Then presentation takes in this infrastructure because you're going to create a dependency injection so we can register all the services. So dependencies, and choose the infrastructure. Now let's rebuild this project. So you can see that we have a project built. Let's go and create dependency injection for each, because you're going to be using the application and also the infrastructure in the presentation layer. So from the infrastructure, we add a folder to this. Let's add a class. Now within this service container class, you want to make this as public static. So we need an iService collection. That is what we're going to return at the end, which will come from, let's look at this. So we need to install this package, dependency.abstraction. And I will say this is add infrastructure. So this takes in iService collection, then service. So at the end, we want to return the services. We need to create same. So let's go to, we can grab this. We need to do same to the application. So let's do that. Okay, so this is what we need to do to register our interface and a service that we're going to get created. Now this is not application, it is not infrastructure. This is application service. Great. So as said earlier on, the domain layer contains our core business logic and entities. And here it is without dependencies or depending on any other layer. It is independent. So let's go and create our domains in there. So here, since you're going to create with a product, I like to have a model that is known as product entity. So in the domain, I want to have a folder, product entity, and in that I want to create a class which is product. It could be a DB set, it could be models. So we have our product, and in there we are having 4 properties in it. We have the ID, we have name, we have price, and we have stock. Aside from this, we need to create a repository interface which will be consumed by the service. So in that, this should happen in the application. That is how we create this abstraction. Now this abstraction, we're not going to use an abstract classes because in clean architecture, it is advisable to go in for an interface. So instead of creating an abstract, we create an interface instead. So let's see. Now in the application layer, this should happen in the application layer. So in the application layer, we're going to create our service. But here in our domain, we need our this interface. So here, once you have this product entity, I'm going to create another folder and name this as repository interface. And in here, let's add an interface, which is going to be a product interface. And within this interface, let's change this to public first. We want to perform CRUD, isn't it? So I have this CRUD interfaces prepared at hand. So we have this, which is taken in the product entity. And we have get all, get by ID, add, update, and delete. Great. Now with this, we want to handle the interaction between our interface and our service using DTOs. The fact is, DTO stands for Data Transfer Object. The reason why we want to use DTO here is it is not all the properties we want to at times collect from the user or display to the user. We want to select the salient ones, the important ones which the user is required to see or required to provide. Example here is, anytime that you're using an EF core for performing database operation in SQL Server SQLite, you don't need to provide the ID. It will be done automatically. So in this case, anytime that you want the user to add product, you are not expecting the user to add ID, isn't it? And if it is not important in there, then I think you shouldn't add the ID at all to the model, so that the user will be tempted to pass in the ID, which will jeopardize the system. So we don't want to do that. So you want to pick only the important ones which are required for the user to fill, and I'll send it. And we can only achieve that using DTOs. So let's create a DTO to handle that. And our DTO should happen in the application layer. So let's go to application layer, because that is what is sit between the interface and also the service. Now in application, let's add folder and name this as product DTOs. This product DTOs, we want to create these DTOs. So let's have them created. Now in this DTO, we need first one as product DTO. So we have a product DTO which takes in from all the properties that we specified. So we can just go in there, grab it, and paste them here. Make sure it is also public. You can use record, but here when consuming it in the client, such as Blazor, you need to create an instance of it if only you want to have it in an edit form. You cannot use that is a record to handle that. So you must maintain the class. But well, if you are working on only API as what I'm doing now, then we can change this to record. It's not going to work. But let's maintain this for simplicity sake. All right, so let's go in there and create our create product. So here we have to go again and create our model. This model is going to be create product. So when creating product, you want user to only provide ID, name, let's say the name, description, and let's say name, price, and stock, right? That's a quantity. So let's change this to public. Then if you want to update it, what can you do? Let's save this first. So add a new class, update product DTO, which takes in the whole model. So maybe you'll be asking yourself, whoa, we have product. When you look at this, we created product DTO. It has the same properties as this update. Why not use update in place of this? Why not use product in place of the update? Yes, you can do it. But you know, in your code, it must be readable and understandable. As soon as you make this as update product, if anybody picks your code, they know that, well, this is going to update, right? And as soon as you see this product, it means you're going to retrieve it. So do the right thing at the right time. Okay, so we have these DTOs, but you know, we need to map this DTO with our entity. You know, we have created entity, this is product, and I believe you are aware earlier on. Now with this, we need to map this to that. There are a lot of mappers that you can use. We have Mapstar, we have AutoMapper, and do you know any other one? Put it in the comment section. We cannot use these mappers to do it, but you know, at times you need to also do something yourself, so you know the in and out, isn't it? You don't normally depend on other people's packages. You can also do yours. You can also build your own, so you know the details of your code. But while saying this is not complex, we can use our own manual mapping interface implementation. But well, when you have a class, a model which has a lot of properties, you cannot be doing this manually. It takes a whole lot of time. So you can use this packages, mappers to map them. I've made a video on how to use AutoMapper, and also how to use this Mapstar. Maybe I'll link them in the video description, or check the playlist and you're going to find it in there. So let's create our interface. And now with this, we're going to, you know, in our application DTO, we have these models, these DTOs, and we're going to also create mapping interface. So, and this coming in the application, because that is where we can interact between our service and our interface, our repository. Okay, so let's have another one, folder, and that will be mapping interface. We are going to create an interface for product mapper, product mapper. So when you have a lot of models, I believe, or I think you should create for each, or you can create a generic one which takes in charge of all, or use the mappers or external packages, and that is all. So we have this as public. This should be interface. So in here we're going to have map to DTO and our map to entity. So you can see we have an update and our product. So here this is going to have an overload, right? So we're going to have two extensions of this, whereby we can pass in DTO update, or we can pass in create. So that is the reason why we are extending this. We have map to, so map to DTO, and a map from DTO to entity. Okay, let's implement this. So let's go in there and create mapping implementation folder in the application, and that is mapping implementation. And in that, let's create a class known as product mapper, which is going to inherit from the product mapper. And here we have to implement the method specified. So for this product, we want to return this new product. We want to return new product of this. We specify the ID, name, price, and stock, because here we're going to get it. So maybe you want to get the product ID as well. When we go to this map entity, we're going to create it. And you know, in creating, we want to only return the name, price, and stock. ID will be added automatically. And for update, we also going to return same as we did in the first one, because we need an ID so we can pinpoint it in the, or fetch it in the database and set these columns, or these column names, okay, to it. Okay, now we have our interface created. The next thing that we're going to do here is we're going to create our use case interface. I normally call this a service. So it's a use case. Now these use cases are going to consume our interface that we have created. The interface is also going to be consumed by a repository, which will be created in the infrastructure, which is linked to our data assets, which has access to a database and also any external service. So within this, let's create our use case, and that is where this DTO is going to sit between the interface and the service. That's the use case. So let's go to the same application layer, and I'm going to make it as use case interface, or you can change it to service, services, whatever. Yeah, it's still going to work. So we have these folders created. We are done with them. Now let's go and create another one. We name it as use case interface. And now within this, let's create an interface. So add new item, and here it should be an interface. We say this is product service. This service also takes in same interfaces or even more. If you want to add more, you can add more to it, because this interface is open and you can add more. And you can see that since we have done the linking, the package references, you can see we have this project reference being added, and we have the models also added automatically. Okay, so now we have this. What's the next thing that we're going to do? We need to create an implementation for this. So I also have another folder in the application, and I'll name it as use case implementation. So when you do something like this, it becomes more easier for people to read. Even if you're not there, if somebody picks your code, well, he can understand what you did. Okay, so let's say product service, and this product service is going to inherit from product service. That is a use case. Now there's an interface. Definitely is going to have some method that we need to implement. They should be public, and I believe you are aware this long time ago. So we have all this. Now, how do we do that? So we need a dependency injection here. So we're going to inject our auto mapper and also going to inject our repository. So here, so this service is going to consume them. So how do they consume it? We're going to use here using primary constructor introduced in C#12. So we're doing that. Else you can create constructor and implement them in there. By the schema, some it is lengthy. Let's simplify this. So here we're going to say that iProduct repository. This is iProduct repository. And we're saying that this is product repository. We're also going to use the mapper because the mapper is sitting in between the service or the use case and the repo. So we need to iProduct mapper. So in the rare case, and you have any package such as the auto mapper and you want to use the interface, that is where you're going to inject this. Okay, so we have this to inject it beautifully. Now let's go ahead and do the needful. So in get all that you're going to do here is we're going to map this. You're going to say that this product is equal to this await because this must be an async. So all the time try to turn your tags to await so you can say the response before returning, so you know what you are doing. So you can see from here we get a product from this everything from here, and now this coming in the form of product entity. We want to return this. That is a list of product. That is a product DTO. So in this we need to select product, and now we map the product to the product list. Coming in after that, we want to convert it to a list. This is returning, getting all, but see where I have put it. Whoa. So that is get all. This should be here. And we should have the async. Yeah, great. So you can see we are done. You see that? Also, let's see get by ID. What are we doing here? Get by ID. So we're going to say that, hey, get a product. After that, map it to product DTO and I return. If it is not null, then return that. But in case it is, then do return null. Okay. The next thing I'll be doing, so this could be null. So let's make this as null. When you do that, it tells you that from the interface, we need to also change this. Else, let's see from this iProduct service, we can also make this as null because it can return null. So we also make it to sync with the method. Okay, so we are good. Let's see the add. In case I want to add, what am I going to do? Let's get the data, convert it to the object, and quickly make an add. And that is all. So we have the mapper, map it, and then consume the service and pass it on. So this service here, this use case doesn't know what actually entails if when it calls the product repository, but all that it knows it, just make it happen. Call this for me. Whatever going to happen at the backside, it doesn't know, but just consume it, and that is all. So we have the one left, and that is an update, isn't it? So for the, we have update and delete. So for delete, we don't need to convert any model. You are not mapping anything. We just call the repo, we pass in the ID because it's an ID which is going to get fetched from database, and as soon as it gets it, well, it's going to scrap that off. So here, for simplicity's sake, we can use the lambda expression, introduce. So we can do that, and we can move this. Okay, now let's see for the update. So for update, it is quite similar to the add, just that we need to change the method name or the interface name. Here must be an async. Convert it, consume the repo. Okay, so we are done here. Now we're going to implement this in the infrastructure. That is where we're going to have the data access, going to connect to a database or even an external service. So let's see from our infrastructure. Let's create a folder known as repository implementations. And now with this repository implementations, let's go and create a class in here. So product repository. Now within this, we need to make this public. So we need to create our DB context. So let's create a DB context first. So we're going to pause on this. Let's create a DB context which is going to be used to generate our database table models or columns. So in our infrastructure, we add a new folder, name it as DB context or data access. So you can just change this. Now this that we have in our app DB context class. And in the app DB context class, we need a DB set which is going to inherit from DB context. Now this DB context we need to install as a package. So with this package, it is coming from entity framework, so we can install this from here, find the latest version and get them installed. And here we are having a DB set which takes in this product entity which is coming from our domain. So we can check from here, we have our domain in this. So now that we have this, we can go ahead and implement this. So let's go to our product repo. And at this product repo, we're going to app DB context. And we say this is context. Now this should come from the folder that we just created. And now we're going to inherit from the interface that we have consumed in our service, which is iProduct repo. This needs an interface that we need to implement. So let's do that. Now in here, we're going to convert this to a list and get it to return. So we can just put it just a list or just a line using this lambda. And this should come as a result of await. Should happen same here. And that is it. Maybe I can put this in next line. Also get by ID, we're doing same. Add product. Or that's an update product. Since we have already converted this to entity, we can just go straight and update it. Now with this, you can see we are using this update. In case it goes in and couldn't find that, then I think it will add it. Well, we'll try that and see when running this. Remind me. If I don't do it, then you do it and give me a feedback. Now let's go for delete. So here with the delete, we're going to do this. We're going to find the product first. And as soon as you get it, you know what you're going to do. We're going to remove it and save. Okay, so that is what we are doing here. Now, in order to improve the performance as well, I want to also talk about the performance. The fast it can use this and also making things simple, not too complex. Here, we are not tracking this. You know, EF cost tracks all checks in DB. So you want to, as no tracking, we can use that because you're not tracking it. You want to just return the list and that is all. Go our way. So let's as no tracking. Also for get by ID, we also want to return it, so we can also stop the tracking. Don't want to track this ID. But this, since you're going to find it, if you want to do this, I think on it use first or default. So find a thing just on a single model, so we can maintain this. This should also be null, so it means you have to go and update this interface, isn't it? So iProduct interface, get product, it should be null. Let's go back. And the last part here is we're going to add. So in this add method, we're going to add that circuit first, make it an async, then we add it and save changes. So we are done with our repository implementation, which gets connected to a database and undo all the magic for us. So the next thing that we're going to do here is we're going to our the presentation layer and consume this. So let's go to our presentation. And in our presentation, we have controller already, but we're going to create our own, which will be product controller. So API controller empty. and we're saying that here product controller, we need to inject the product service. We are not consuming the product repo, we are consuming the service. So we consume the service in here, and we can go ahead and specify get all, whereby we specify the service has a method known as get all product. Then we can pass it on. We can also get by ID. We specify the ID of it and also return it. So we call the same service which has this endpoint or this API. Then we can return. In case we couldn't, then return not found. Else, you know the drill, right? Then here we're going to talk about create. If I create new product at the end, I want to see what I created. So we need create product DTO as a payload. We called our service, then we pass at the end. We want to call this method get by ID, and now we specify the product ID here, and that is all. The next thing that we're doing here is update. If I want to update, we're going to use a method of HTTP put, and that's going to help us update it. So it is coming from the body, so we specify our product DTO, and in here we need to call our service, then passing this product DTO. The next thing that we're doing here is it is a delete. So we need a service. We've created a service already, so we call the service, and I return no content. As soon as it gets deleted, kindly return no content. Great. So we have this created and configured nicely. Now the next thing I'm going to do here is we're going to register this in the various dependencies. So let's go to the application. Now from the application, we created an automapper, not an automapper, we created a mapping service to handle it. So we go to our dependency injection, and in here we're going to say that builder.services.map. We can add it as scope or singleton. We want to map the I product mapper and this. After that, we also have our service. That is where this mapper is sitting between. So we need to also make that happen. Now we cannot use builder here because we are not building any app. All that we can do here is use a service that we have exposed, and that is what we need to do. After that, we need to also go for the infrastructure service container, and in here we have also used the repository, right? So we need to also register this repo here. We say this services, then .add scope, we specify the product repo, and now this. So we are good. Now what is the next thing that we're going to be doing? We go in and what again? We need to build this, isn't it? And consume this in the consume the service here. So let's go to that presentation program, and in here we're going to make this happen. Now first, let's check the dependencies. Which one is it using? When we go to dependencies project, it is using the infrastructure. Now this should use the application. So let's remove this. Then let's add project reference, this application. Then we're going to add this. Now let's see first. So here we're saying that using demo CRUD.application.dependency injection, and we can go ahead and say builder.services.add application service. You see, now we need to perform database migration, and this migration is happening in the infrastructure. So it tells you that, hey, we cannot go without adding the infrastructure service to this, because this must be the place of migration, but which reflects in infrastructure. So it tells us that we need to add that. And you know that the infrastructure has been has this application as part of its dependencies. So including the dependencies separately, adding this application dependency separately, and also adding the infrastructure which has the core root of this application, it looks like you've added it twice. So let's see. Now we go back again to the dependencies of the project. Let's remove this application and dependencies. Let's add infrastructure and check it out whether this is going to get solved. Okay. Yeah, it is. You can see. So when you check the dependencies of the project here, you can see we are having only the infrastructure. But well, open this. You have all the application here, you see? And we have the application also has the domain as well. Great. Now let's go and add the infrastructure over here. And before we can do it, let's make a duplicate. Change this to infrastructure. And here, you're going to say add infrastructure service. And that is it. We need to install EF Core to update migration. So I click on presentation, dependencies, management get packages, and browse, and type in tools. And when this is done, we can follow the command here to perform a migration. We're going to be using the first one, and which one? Which one again? The last one. So first and last. First, last, last. Okay, so now this is done. Let's go and build that. So we can use .NET build to build this first. Now we need to make our presentation as startup. Then in our package manager console, after this is built, we make the infrastructure as a default project. This is amazing. We have no error, we have no warning. So when you follow the clean architecture with this solid principle, at the end when you build your project, you won't have any error as you've seen here. This sounds amazing, right? Now let's go and make this as a startup, and let's add. So we haven't, I've remembered, we haven't created a connection string, and I believe you've done that, isn't it? I heard you say, hey, stop. You haven't done the connection string. And yes, of course I haven't, but I want to perform migration. How is this possible? So let's wait for this file to get created. Then we're going to set it up in there. So if you try to build this, what we haven't? Yes, of course, I raise my hands. It's understandable because you haven't registered a DB context and you want to create it. Well, what the hell? Where can it be found? No. So we need to go and do that. Let's go to solution, and here we have a DB context created already, and we have a EF also created, but we don't have a connection string, isn't it? So here we can go and we can perform this connection string in the app settings, and I'll use iConfiguration to get it. That is the best practice, and I believe we should follow that. Since we are following the best practice, the best ever architecture, and the best principle of design, and let's do that. We go to our app settings, and in here let's have our connection strings. Let's say this is default, and we're going to be using SQLite, SQL Server, SQLite. So let's say data source is equal to CRUD.db. So that is a database connection string. Now I'll just grab this. Let's go to our program.cs file, and now in the infrastructure, let's pass in builder.configuration. Let's go and receive that. So in service container, let's add I configuration. Then we say config. So maybe we need to install extension.configuration.abstraction in our use local version of 8. We're doing that in the infrastructure. So here we need to have our services.add db context. Specify your app db context, and which takes an option. So we're going to say this option maps this option dot use SQLite. We haven't installed the SQLite, so let's go and do that. So from the infrastructure dependencies, manage packages, SQLite, and now let's go and do justice to that. And here we need to add config.get connection string. What is the name? That is it. So let's rebuild solution. Succeeded. Amazing. Let's go back. Let me clear this so you see that we are not having any issue. So that is done. We have a file created. Let's go and update database. Great. Let's run this and check it out. So our endpoints are ready. Let's give it a try. We have to make sure our database is attached, and of course we got it. So we should get null, and it's great. Let's go and add default one of 100, price 1000, maybe whatever. Pass in. Let's add and see. So this has been added. We can go and get by ID of 1. Now we have it. We can update it. That is 1. ID is 1. That is updated. Let's specify this to 10 and this to 5. Update this. Okay, so the product detail field is required. Let's see the reason why. Okay. Execute. Yes, 204. Let's go and get by ID. The same one. Now you see we are having it. We can go and delete it. Pass in the ID of 1. And now it's been deleted. Let's go and get it again. Watch it. Not found. Great. So now that we have our CRUD working nicely and beautifully, let's go and access this using the solid principle. So let's first access it with our clean architecture. So you can see we created our, let me just make this smaller so you can see yourself. Let me open this. Okay. Now if I put the solution explorer, let me okay. Now we are having 4 layers. Look at this. We also have 4 layers. Where is it? We have 4 layers, right? Okay, this could be here and this should be here. Great. You see we have an application, and this application is where we have our use cases. So if I open this application, we had our use cases. I think I should put this here, then this should go this side. This should be here. Great. Application has use cases, and now these use cases, it is what termed as our service. We created that. The domain has our entities, our DB set, and of course we have it with our interface. We have our infrastructure which contains an external service, and in this case we are connecting to our database. That's a DB set. So infrastructure, we have a DB set, and also the external service, which is in fact the repository that we have here. Then we have an endpoint for our presentation, and that's exactly what you see. So you see all this, what we're doing here is we have an endpoint consumed, and that is all. We added a service, perform migration. We did nothing much here. The controller is what needed, and that's the name as the endpoint. So you see we're able to follow this architecture nicely and beautifully. Of course, we got it. Now let's go and access the solid principle. The first one is saying that single responsibility principle, that's an SRP. And yet it's saying that a class should have only one reason to change, meaning it should have only one responsibility or a task. We shouldn't create a class which has, two tasks, maybe update and delete at the same time. No, split it. Update as a task, delete as a task. And did we do that? Of course. Where? Each class has one reason to change. That is a product repository, and each handles separate data access. So when you check our repository from here, this infrastructure, our repository, you can see that from this, let me open it idly. You can see from here that each has one task: delete, save. That is add, right? We don't have add and delete. No, we don't have add and update. We have add, we have update, we have get, we have get by ID, we have delete, we have update. So you see each task has its own way of handling things. One task, one function. The second one here is what? So go here. We have the second one is that's an O for solid, and O is open or closed principle, OCP. And here it is saying that classes should be open for extension by closed for modification. Meaning if you want to, you should be able to extend a class behavior without modifying its sources or its source code. Let me give you this scenario. Let's say you want to create a service which sends an email, or maybe which adds data to the database using SQL Server. And this is what we have. We have an SQL Server using an EF call. Now, if you want to create another one which is for Dapper, we don't need to come and modify or clear this service, and add Dapper configuration. No, it shouldn't be modified. Rather, we should have a way that we can create another service, another method to handle that. And that is a way of creating an interface. When you create an interface, you have an implementation of this new one, and you can add that to it. And of course, we created an interface whereby we can extend multiple repositories. So we've also applied the O. Let's see the next one, LSP. That's a Liskov substitution principle. So subtypes should be substitutable for their base types without altering the correctness of the program. Essentially, derived classes must be replaceable for their base classes without affecting the functionality in this. So you can see that from here we have only one repository, and that is a product repo, and that is this one. Now we are not creating any additional service which is going to inherit or implement this repo. So here the value or the original value is going to maintain, or the behavior of this task is going to maintain anywhere that you call this. For instance, when you have a service implemented and it has get all product async, and here it is checking or it is updating the product prices, meaning it has violated this law. Because when you use this service anywhere, it should not modify the originality of the data. You should preserve what we have. So let's say, assume in case you have another service in there and you want to have this, the best idea is to create a service separately for that, and handle that in there. But for now, we are not creating any. We have only one repo, which is a product repo. So we are good to go. Now let's see the next one. And you're talking about the interface segregation principle. Here, a client should not be forced to implement interfaces it does not use. Instead of having one large interface, create smaller or more specific ones. Our iProduct repository and our iProduct service are not crammed together. We have segregated them, and each of them has their own implementation that they need. So as you can see from here, when you go to application, we created our iProduct service, which is a use case or a service for itself. Aside from that, we came to the implementation, and that is a contract of the interface, which is found in the demo or the domain. We also created one in here. We did not create one for all, so we have separated them. We have segregated them. Each is having its own function to perform. Okay, now the next one that we need to talk about is, let's see, the dependency inversion principle. Here they're saying that high-level models should not depend on low-level models. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. Now we see from here, abstractions in clean architecture, we are focusing on interfaces, not class abstraction. You know, class abstraction has a default implementation of method, and as soon as you inherit from this class abstractions, you are going to override them. But for interface, you define the method signature, the method name, and you go in and implement it in there. So in the interface, it doesn't have any pre-defined method. It has only the method name. And in our controller, we saw that our controller is dependent mainly on the interface, the abstraction. So let's check our interface. From the product controller, you can see that we injected the service here, which is the interface. This interface is not the actual class, right? It's just an interface which implements the class. So here we have also achieved this dependency inversion over here. So you can see the two texts that we introduced, talking about the clean architecture and also the principle, we've achieved that in building our CRUD endpoint. That is the best way that we should go. Actually, there are some things that we can modify, okay, to suit what we want. But at the end of the day, we must make sure that we do exactly what this principle is asking us to do, and this architecture has for us. All right, so I believe this is clear. Then I will end here. Okay, so what have we done so far? We've just built a robust CRUD API using .NET 8, guided by the principle of solid and also clean architecture. So by following these principles, we have not only created a working application, but also laid the foundation for something that is easy to maintain, extend, and scale in the near future. So if you enjoyed this video much, then do not forget to like this video. And also, if you are new here, subscribe for more deep dive into .NET, architecture patterns, and all things coding. Alright, so if you have any questions too, you can drop them in the comment section. Thanks for watching this, and until next time, keep coding and keep creating. See you in the next video.